좀 이렇게 떨면 괜찮아지지 않나요? 이빨 벌레면 좀 괜찮아지지 않나요?
Alright,
몸에서 따뜻해지려고 계속해봐요.
endocrine system is related to hormones and messages sent through the body. These are the organs related to it. Male and female have slightly different ones, but they serve the same purposes. Estrogen and testosterone. So why are hormones needed? They are chemical messages from one body part to another. They communicate, their communication is needed to coordinate with the whole body. They are in charge of homeostasis and regulation. And what is homeostasis?
Your optimal level of body. Normal.
Trying to keep a normal level, not too hot, too cold, not too acidic or basic, not, what else?
Just a suitable body condition.
Just a suitable body condition. So therefore homeostasis and regulation, such as metabolism, growth, development, maturation, and reproduction. So what kicks in growth is hormones. When do you grow the most?
During sleep.
What part of your life do you grow the most?
Teenager.
What is that age called?
Critical period? Critical period?
Starts with a P?
피베리.
Puberty. Alright, so puberty also kicks in some growth hormones. So
They're growing to reach their homeostasis?
How's it related to? It's more for regulation, and it's not so much necessarily homeostasis. It's for continued development and for reproduction. So your growth changes. You get taller and wider, and different parts of you change at different times. We can talk about that in sexual reproduction as well. But you've all gone through puberty at this point, so you know how your body has changed since you were 10 years old. It's different. Things are different than they were before, and that is due to the growth hormones. So in order to have regulation and communication, animals and humans rely on two systems for regulation. Yeah. So animals and humans, so we have the endocrine system, which we're talking about now, the nervous system, which we've already talked about. The endocrine system has a bunch of ductless glands. A duct means that it comes out of the body. So like tear ducts are right here. They produce tears out of your eyes. There's oil ducts connected to the oil glands in your body. If you have an oily face, you have a lot of those glands. Blackheads and whiteheads?
No. What do they call it as a whole?
They're glands, oil glands.
I was like, it said SEB.
Sebum? Yeah, those are related to glands. But these glands do not have ducts, so that means they're internal. And they secrete chemical signals directly into the blood. So you've got a bunch of them. You've got the bow tie around your neck. You've got the ones on the organs in your stomach, and then you have ones on reproductive organs as well, also in the brain. And these chemicals travel to target tissues. So it will go from the glands here to wherever it wants it to go. And we'll talk about these places.
Are they in their dermis?
No, these glands are internal mostly, close to organs.
Aren't they in the skin? Like some glands?
Not these kind of glands. Not related to the endocrine system. Yeah. Okay. So endocrine, the chemical signals sent by the endocrine system are slow and long-lasting responses. This is different from the nervous system because the nervous system has neurons, and a central nervous system, and the messages get sent electrically, not through chemicals, but electrically. And these messages are fast and short-lasting responses versus the endocrine messages, which are long-term changes. So a nervous system message would be like, kick the ball. You don't kick the ball for the next 10 years. But if the endocrine system sends a chemical message that says, it's time to grow, you'll be growing for a while. And their messages are different lengths, but anyway. So, you get regulation from both of these systems, the nervous system and the endocrine system. Here's those neurotransmitters released by the neurons. They'll be accepted by receptor proteins and affect the muscle. Then hormones will be released from the blood, and they have their own type of receptor proteins to affect the target tissue as well. So, there's two types of hormones. There's protein-based hormones and lipid-based hormones. There's polypeptides, which are small proteins like insulin and ADH. Not ADHD, but yeah. Then there's glycoproteins, which are large proteins and plus a carbohydrate. These are FSH and LH. I'll attach a list of what these mean.
Are the fat-based hormones like the deepest part of the skin?
So they're not on the skin level, remember. Then there's amines. There's ones that are modified amino acids. So epinephrine, if you remember the amine groups, they had specific names. And melatonin.
That color? Melatonin. That gives the color.
Melatonin, no, that's melanin. This is melatonin. Then there's lipid-based hormones. So these have protein attached to these, and these have what? What are these?
Do you have to memorize all of the names?
I'll give you this list. Yes. Lipid. What are lipids?
Oh wait.
What is a lipid?
Lipid. Fat.
Okay. So there's fatty lipid-based hormones, and these are steroids, which can be cholesterol, like sex hormones, and aldosterones. Okay. All right, so how do hormones act on target cells? Lipid-based hormones and protein-based hormones react differently. Lipid-based hormones are hydrophobic. What does that mean?
They hate water.
They hate water. They avoid water. They avoid water, and they are lipid soluble. What does lipid soluble mean they can do?
They can dissolve.
What is a lipid that they can dissolve through? What kind of layers of lipids could they go through?
What? Lipid bilayer.
A lipid bilayer. So what can they go through?
Through
They're too big.
What is made of a lipid bilayer?
Protein. Carbohydrate.
Hydrophilic.
I know what's inside the lipid bilayer, but
What is the lipid bilayer?
the tail and the.
What is this? What is the
Hydrophobic tail. Hydrophilic head.
So these are made of lipids, and those lipid-based hormones can go through there. What is this? What is this?
With numbers.
Wait!
Long-term memory. Oh gosh. Please give us some time.
What's on this side? Cytosol. What does that mean this is? Plasma membrane or a cell membrane. Yay!
Hey, what do they call that thing?
What?
Lipid bilayer.
So this is the lipid bilayer. So lipid-based hormones can go through the lipid bilayer. So they can go through a cell membrane, or they can go through a nuclear membrane and go to the nucleus. So they can enter cells. That might burn up. I wouldn't do that. They can bind to receptor proteins in the cytoplasm or in the nucleus of the cell. And lipid-based hormones can even bind to DNA and become transcription factors. So what does that mean?
Transcribe.
What does that? So what does that mean they can do?
It becomes amino acids and it becomes protein. What?
Tell me. Wait. Yeah. So what does that mean? The hormone can do what?
It replicates another DNA strand.
So it can make a segment of DNA actually replicate. Okay. Then there's protein-based hormones. They're hydrophilic and not lipid soluble. So what happens to them?
They love water.
They love water. What can they not do?
They cannot go. They're saturated, so they cannot enter the cell.
They cannot go across the membrane. So they have to trigger a secondary messenger pathway. This will make a bit more sense. A minute. And they activate a cellular response, like an enzyme action or uptake or secretion of molecules.
Are trans fats unsaturated or saturated? It's unsaturated.
I'm not on that page right now. Trans, I think, are
the worst fat.
Miss Emily.
the one bent.
Yeah, so it's unsaturated.
Can protein-based hormones go through the membrane if they are with enzymes?
What's
enzyme
action?
Is there another way?
So here is a lipid hormone. First, the lipid hormone comes from the blood. It goes from the blood and then it goes to the extracellular matrix. So it's out there. It finds its target cell and it can diffuse through the membrane. It either attaches to a receptor protein out here, does what it needs to do, or it could be on a receptor protein in the DNA where it can act as what? What can it be here?
What part?
This is the lipid hormone. Huh? It's by the DNA here. What is it doing?
It becomes protein.
No, it's still lipid. What is it doing to the DNA? We talked about it a minute. How? It becomes a transcription factor, transcriptive factor. So it makes a certain part of DNA turn into mRNA.
Transcription.
I don't think we talked about it here.
Which comes first, translation or
Transcription.
Yeah.
Transcription, then translation.
먼저 웹페이지를 한 다음에 그다음에 그거 translation.
translation 먼저 오는 거.
translation DNA replicate 하고 translation은 그 아미노 맞추는 거.
So
transcription이 뭐라고?
alright, so it can become a transcription factor and it will read off a part of the DNA to create proteins. There's parts of your genes that are not read your whole entire life. They're only read at certain parts of your life, like things that happen in puberty, like so how tall you're going to be, how certain parts of your body will change as you turn into an adult. They're not shown in your DNA immediately when you're a child, but somewhere a lipid steroid hormone will go in there, attach to your DNA, and allow that bit of your DNA to finally be read to form protein.